Yeah, this demonstration will look at the cross-sectional data analysis. The first thing that you will see is this little dialog box that you are seeing here, and it's trying to show you exactly what you should have in your data sets. And when you are set, you just type Y, and that is for years, and then press enter. And then it now take you to this cross-sectional data definition form. Now we are going to, based on what we have on the system, we are going to now do some. Now the dependent variable for this the data set which I'm going to use is profit. And then independent variable here, pre-tax 1. Okay, whether pre-tax 1 or pre-tax 2. Pre-tax 1, pre-tax 2, 3 now, because we have 1 where, okay. Even that pre-tax 1 wasn't correct, so remaining X. Good. So now we can add other variable to it, like incentive 1, then incentive 2. That's incentive is not also correct, so incentive 2. I have to make sure that whatever you are entering is correct, otherwise it means you are going to do the work. Okay, we just have about 5 dependent variable here and 1 independent variable. Okay, we can make it up to 6 as incentive number 3. So incentive 3 is what makes it up to 6. Now, the year that we want to analyze is the year 2012. Let's see how all of them we look for. Now, this particular one here is the column head that holds the year or the time, and then as it is in your data set. And then this one that the cursor is going over is the column head for the entities, that is the firms, countries, or whatever that you are trying to, that is holding the names of the entities you are trying to compare the data for that particular period. Now, I just gave an example of firm 1, firm 2, and firm 3, but actually I had something else which is different from the data set. Let's see. Okay, now let's see if we can have something. Okay, there's a place where I kept, there are so many names, so I have to type it. Now this is, we copy from here, and then we come to this place, we paste the names here. So these are the names, assuming that we have names like Bank 3, Cons 3, Cons 2, Cons 1, Cons Serve 3, Bank 2, Serve 2, Bank, Serve, Manu 3, Manu 2, assuming that these are names of companies anyway. And actually I did this so that it covers about, I think, 3 or 4, I think about 5 sectors: oil, bank, manufacturing, service industry, and then construction industry. So this we are going to analyze them for 2012. Their profit and all this. We see how it will going to be. So having done that, we'll now go on to the names where the name to enter the name of the data set. We say the name of the data set that I saved it, which is cross-sec. That's the name. And then having done that and seeing that nothing is amiss, we press or we click process cross-sectional analysis. Yeah, so it is just telling us that it has been done. The output for this cross-sectional analysis is saved to user value style cross-sec result and so on and so forth. So now we click OK, and it starts showing us the graphs. These are the graphs, the output graphs for it. And of course, you can see the names of the company as their pair. And you can see from here, you see performance by entity in 2012. Now, the graphs have 4 types. As we close this, another group of the graph will just come in now. Now, this is the bar charts for the same group. And then we close this again, and then this is the histograms, and then I close this also. Now this is a beautiful one. That is a pie chart of the profit for the performance of the companies in 2012. You can see it. So, and that's it. And then I think there's another one that is still okay. This one is was supposed to be the box plot for the same performance in the 2012. Yeah, I can see it. Box plot of profit for entities in 2012. And that's it. Okay. So now, having shown you this, now let us now go to the file proper. Now, this is where the output was generated. So let us expand this and see. Yeah, that is the expansion. Now, you see, let's see. Good. This is it. This is the beginning. See the data set used. See that the only year that was picked was that of 2012. And these are the, what do you call it now? The independent variables. And look at the dependent variables here. They are second to the last, and then the entities, the name of the entities that were analyzed are also there. So now, the descriptive statistics also comes in there. The descriptive statistics, and then, of course, you also have the correlation matrix, which is there. Because this the number of variables are kind of more, so the program just compacted them so that they can be seen. But now this Watson test, that is this one. The data set is the Watson is showing that it has 0.8191. And the verdict here that data set is serially and negatively correlated. So this is the BDIF differences, and then this is the one that is following is what we call covariance of differences. Now this BDIF is parameter differences. Now let us now look at other one. Now look at the Horstman test. The Horstman's test is showing a negative of 0.0 0.001, when the p-value of a perfect one, that kind of a thing, showing that, that it is not significant at all. Now, this is the fixed effect model summary, for that, and then with some other either warnings or information concerning what things that for you that you should expect or not to expect there beneath. Then after look at the random effect model that you see here, also the model summary, and this is the random effect model summary that is here. Let's look at this. You see the R squared for the random effect summary is 0.557, while the adjusted R squared is 0.387. The F statistics is 3.276, and then the probability of F statistics is 0.0393, which still shows that the model is fit enough, since it didn't go outside the 0.05% threshold. But now look at the fixed effects. They are basically the same thing. So, but now let us now go forward to see what happened after the random effect. Then this is judging from the Horstman specification test. The verdict that the program is trying to return is that it failed to reject null hypothesis. So it's asking us to choose random effects RE model. And then here, it's now repeating the same thing that it has done. But then after doing that, it's now showing us Driscoll-Cray OLS correction summary, which is a bit well, not too different from the other one, but the F statistics is surely different. The F statistics is different. So that is that. And when you look at the p-values, you can see that for the Driscoll-Cray OLS, almost all the variables were significant except two. The ones that are not significant are incentive 1 and incentive 2. So all the other one, pre-tax 1, they are all significant, and even incentive 3 was also significant. Now let's check what happened in the other ones, that is before the Driscoll-Cray own. Yeah, before the Driscoll-Cray, we have the random effect, and that one is showing that, well, almost every other one too were the same thing, but then the level of the p-value differs. Let's see what happened at the fixed effect. Well, the same thing, and the same, just the same thing. So that is on that. And then at the end of the Driscoll-Cray own, you have so many other things you need to look at, and you also have a Driscoll-Cray test result parameters, which give us this, and then you also have the standard errors for the Driscoll-Cray, which is this one. So, and then that is the last. So with this one, you can pick your results and then do your analysis as you wish. So that is for the cross-sectional analysis.